an infinite fractal universe of basically an infinite number of things.
Welcome back to our channel, where today we're diving deep into an exciting development from the cosmos. The James Webb Telescope has just released some declassified photos of Pluto, giving us a fresh look at one of the most mysterious objects in our solar system. Stick around as we explore what these new images reveal and why they matter. Imagine a universe where infinite Big Bangs ignite endless possibilities. This is what Dr. Brian Cox suggests: a fractal cosmos beyond our wildest imaginations. But let's bring it back to something a bit closer to home: Pluto. Once just a frozen blip in our textbooks, everything we thought we knew about this distant world was turned on its head by ENASA's New Horizons probe. As it zipped past, New Horizons peeled back layers of mystery, revealing secrets that continue to captivate scientists today. Join us on a journey beneath Pluto's icy exterior. We'll traverse icy landscapes, towering mountains, and discover phenomena that defy our expectations. Could there be life here? The possibility is more real than we ever imagined. Beneath Pluto's rugged ice, whispers of an ocean stir. Renowned physicist Brian Cox speculates that this hidden sea could harbor life. It sounds fantastical, but the clues lie in the heart of Pluto itself. This isn't just a frozen wasteland. It's a dynamic world with water ice mountains and flowing glaciers, all hinting at the ocean below. What the mission scientists have witnessed has astounded them. Despite the intense cold, the presence of freshly formed ice suggests active geological processes, reshaping Pluto's landscape right under its icy shell. The excitement doesn't stop there. William McKinnon, a key scientist on the team, believes this icy veneer increases the likelihood of an ocean's existence beneath. For the first time, water ice has been spotted on the mountains of Pluto. Alan Stern, the leader of the New Horizons project, is optimistic about the abundance of water still to be discovered. Back in 2015, the evidence was merely suggestive, but now, years later, scientists are closer than ever to solving this galactic puzzle. Why the fascination with Pluto's ocean? The answer is simple yet profound. An ocean on Pluto isn't just a discovery, it's a revelation, opening up new possibilities for life in our solar system and beyond. Stay tuned as we dive deeper into these mysteries, unraveling the secrets of a world that continues to surprise and intrigue us. Imagine the possibility of life thriving in the icy depths of Pluto's ocean. Brian Cox, a visionary in his field, entertains the thrilling possibility that Pluto could harbor life. He suggests that the waters there might be just warm enough to support living organisms. Imagine a small, distant planet, seemingly inert, yet potentially teeming with life in complex organic chemistry. It's a thought that's nothing short of mind-blowing. Brian Cox is more than hopeful. He's confident about his theory. He proposes that if our understanding of life on Earth has even the slightest flaw, then perhaps Pluto is not as barren as we once thought. It might even be home to its own unique forms of life. However, proving this is challenging. The New Horizons probe, while revolutionary, might not be equipped to confirm the existence of warm waters on Pluto's surface. Instead of focusing solely on Pluto, Cox advises looking closer to home at the moons of our solar system's giant planets. Jupiter's moon Europa, along with Titan and Enceladus of Saturn, offer promising sites for the search for extraterrestrial life. Titan, with its subsurface ocean, and Enceladus, which ejects liquid into space, provide accessible means to search for organic materials. While the hidden ocean of Pluto captivates the imagination, it's the moons of other planets that present the most probable sites for discovering signs of life. Cox explains that the evolutionary leap from simple, single-celled organisms to complex, multicellular life forms is exceptionally challenging, akin to squeezing through a narrow passage. This rarity suggests that complex life forms are likely scarce across the cosmos. However, Cox offers an intriguing perspective. Wherever there's water on Earth, there's life. Given that the materials that compose our solar system are fundamentally similar, it's logical to surmise that life could potentially exist in the waters of Pluto. Yet, he cautions us to temper our expectations. If life does exist on Pluto, it's likely to be simple and primitive, far from the fantastical creatures of science fiction. In essence, the search for life extends beyond mere biology. It's a quest to understand the broader possibilities of life throughout the universe. Imagine uncovering signs of life on Pluto. No matter how simple such a discovery would be a monumental shift in our understanding of the cosmos. Scientists are increasingly optimistic about the chances of finding life on Pluto, largely because there's still so much we don't know about this distant world. At the heart of this mystery is what NASA has affectionately termed Pluto's heart, a colossal nitrogen iceberg spanning 1 million square miles, the largest glacier in our solar system, nestled within the expanse of Sputnik Planitia. Initially, astronomers speculated that this unique feature formed from a cataclysmic collision with another celestial body. However, its peculiar location, directly opposite Pluto's brightest moon, Charon, casts doubt on this theory. The odds of an impact precisely at that spot, opposite Charon, are astronomically low, leading scientists to consider other possibilities. They now suspect that a phenomenon known as polar wander might be responsible. This occurs when a planet's spin axis shifts due to significant geological events. Sputnik Planitia's position might be strategic, chosen by nature itself as an ideal cold trap, where nitrogen ice has accumulated to depths of at least 2.5 miles. This geological setup suggests an intriguing possibility. Beneath its icy facade, Pluto might harbor an ocean, influencing its orientation to always face Charon. The substantial weight of the ice and Charon's gravitational tug have caused the basin to tilt, aligning more closely with the gravitational axis between Pluto and Charon. This adjustment likely triggered the cracking of Pluto's surface, leading to the formation of vast faults that stretch across the planet, beginning in the northwest near the North Pole. As more ice accumulates in the basin, Pluto continues to adjust its stance, a planetary dance that underscores the dynamic nature even the most remote bodies in our solar system. These discoveries not only enhance our understanding of Pluto, but also remind us of the profound mysteries that still lie waiting in the far reaches of our solar neighborhood. In a recent episode of the BBC show The Planets, Brian Cox unveils a captivating mystery on Pluto, focusing on a region affectionately dubbed Pluto's Heart, but technically known as Sputnik Planitia. This area, marked by an astonishingly smooth surface and flanked by towering mountains of frozen water ice rising up to 6 km above the surrounding plains, defies the usual rugged terrain of this distant dwarf planet. As Dr. Cox explains, while most of Pluto is scarred by craters from cosmic impacts over billions of years, Sputnik Planitia is an anomaly. It's unusually smooth, lacking the craters that pockmark the rest of Pluto, which makes it a rule breaker in planetary geology. This extraordinary smoothness sets it apart as a unique feature not just on Pluto, but in our entire solar system. Zooming in, the surface of Sputnik Planitia reveals a mesmerizing network of polygonal shapes, each spanning at least 10 km. These formations resemble cellular structures under a microscope, yet they are not biological. Instead, they are the result of Pluto's internal heat struggling to escape from beneath the icy expanse. This thermal activity causes bubbles of nitrogen ice to rise and fall, creating patterns reminiscent of a dynamic lava lamp. These intriguing shapes are distinct from any glacial forms observed on Earth or elsewhere in the solar system. From afar, Pluto shows no signs of impact craters, but as we examine it closer, the mystery deepens. The New Horizons spacecraft captured crisp images of the frozen nitrogen surface, revealing a complex tapestry of hexagons and pentagons stretching across it. This suggests that while nature may follow similar patterns elsewhere, the phenomenon observed here is profoundly unique. Dr. Cox attributes these bizarre patterns to convection, the movement caused by the heating and cooling of the nitrogen ice. This process makes the ice rise when heated and sink upon cooling, a fascinating dance of elements that underscores the dynamic and still mysterious nature of Pluto. Pluto, a tiny world on the outskirts of our solar system, is buzzing with surprises. Among the most fascinating is the unique and complex pattern of its terrain, a revelation that has left scientists astounded. But what drives this dynamic activity on such a small, seemingly inactive planet? Some scientists propose that the secret lies within Pluto's core, which might contain radioactive elements. As these elements decay, they release heat. This heat could be the force melting the nitrogen ice, causing it to rise and sink in, a mesmerizing cycle that keeps the surface of Sputnik Planitia ever-changing and vibrant. This discovery not only suggests that Pluto is far more active than previously thought, but it also supports the tantalizing possibility that an ocean of water might lurk beneath its frozen crust. The evidence? Data from NASA's New Horizons mission revealed that Sputnik Planitia is positioned over a mass anomaly, likely an ocean, which has significantly influenced the reorientation of Pluto itself. Further clues come from the tectonic patterns captured in images by New Horizons. These geological features are typically signs of subsurface activity, perhaps an ocean hidden deep within. It's thought that around 4 billion years ago, a colossal impact from a Kuiper belt object measuring 50 to 100 km in diameter carved out a massive basin in Pluto's icy shell. This cataclysm likely created a thin, fragile layer at the base of what now forms Sputnik Planitia. In the aftermath, an ocean beneath this indent may have surged up, exerting pressure that fortified the overlying crust. Over millennia, layers of nitrogen ice accumulated, creating the landscape we observe today. The swift formation of this liquid ocean beneath the surface hints at a dynamic and complex history, offering compelling evidence of its existence, although not definitive proof. The mystery of Pluto's ocean deepens when we consider the planet's formation. Scientists once believed that Pluto formed slowly, accreting cold material from the surrounding debris of the solar system. Over time, the internal heat from radioactive decay and gravitational compression might have melted part of the icy accumulation, potentially giving birth to an underground ocean. This evolving understanding of Pluto challenges our perceptions, inviting us to rethink what we know about the most distant members of our solar system. The question remains, what other secrets does Pluto hold beneath its icy exterior? The once prevailing theory that Pluto's subterranean ocean stayed warm thanks to radioactive decay has recently been put under the microscope. In a groundbreaking study released in June 2020, scientists explored the possibility that Pluto might have been a hotbed of activity from its very inception, forming through massive collisions similar to those that shaped Earth in its primordial days. This study led to a startling conclusion. Pluto's hidden ocean might not just be a recent feature, but could have been a constant presence for billions of years. Such a revelation electrifies those in the scientific community who dream of discovering life beyond Earth. While Earth itself was still a fiery globe of molten rock, Pluto, distant and serene, was already cultivating its own watery haven beneath the surface, potentially a cradle for life. By integrating computer models with data collected during the New Horizons mission, researchers have begun to paint a new picture of Pluto's origins. Surprisingly, the data suggests that Pluto started out intensely hot and has harbored an ocean beneath its icy shell since its formation. This challenges previous notions about the dwarf planet's past and suggests that liquid oceans may be common in the outer reaches of our solar system, not just rare anomalies reserved for Earth like planets. Alan Stern, the principal investigator of NASA's New Horizons mission, asserts that these findings are revolutionary. If oceans are common in the outer solar system, then everything changes, Stern remarks. This shift in understanding opens up exciting new possibilities about the prevalence of life on other celestial bodies. The flyby of Pluto by New Horizons in 2015 provided the first glimpses of its complex, colorful geological surface, sparking speculations about the watery depths below its frozen crust. These speculations have since solidified into a consensus among planetary scientists. Pluto likely hosts a vast liquid ocean enveloping its core. Today, the image of Pluto has transformed from a mere icy rock at the edge of our solar system to a dynamic world with secrets that could redefine our search for life in the cosmos. This journey of discovery not only challenges our perceptions, but also deepens our understanding of the mysterious outer solar system. Carver Beerson, a graduate student at the University of California, Santa Cruz, led a fascinating study aiming to unlock the mysteries of Pluto's formation. He explains that while we've learned a great deal about the inner solar system from asteroids and other data, the outer solar system where Pluto resides remains far less understood. This study hopes to fill in those gaps and offer new insights into Pluto's early history. A central question the study seeks to answer is whether Pluto started out cold or hot. It turns out the key to solving this mystery lies in examining Pluto's surface. Just like how water behaves when it freezes and expands, the geological features of Pluto can reveal clues about its past. Alan Stern, head of NASA's New Horizons project, compares it to putting a glass of water in the freezer. The water expands and cracks the glass as it turns to ice. Similarly, if Pluto started hot and then cooled over time, its surface would have expanded, leaving telltale signs of growth. Water molecules, when frozen, arrange themselves into a crystalline structure that takes up more space than when they're liquid. That's why ice floats in your drink. On Pluto, if it started hot, this expansion should have left visible geological features. But if Pluto began cold, its surface would have compressed over time instead. To find out which scenario fits, the team analyzed data from the New Horizons mission. They were stunned by what they discovered. Parts of Pluto's surface appeared incredibly ancient, perhaps as old as the solar system itself, and there were no signs of surface compression. This led Beerson and his team to conclude that Pluto likely got off to a hot start. One example that supports this theory can be seen in Pluto's craters. Typically, craters on icy worlds are neat circular marks left by collisions. But on Pluto, these impact craters have expanded over time, further reinforcing the idea that Pluto's surface grew as it cooled, rather than compressing as it would have if it had started cold. Even in the oldest regions of Pluto, it's strange there's no sign of surface compression. This is a key clue for scientists like Carver Beerson, who modeled Pluto's formation using the idea of a hot start. His model shows that if Pluto formed through a series of massive impacts, one after another, the heat from those collisions would have kept a liquid ocean beneath the surface. But for this to happen, Pluto would have had to form incredibly quickly within 30,000 years or less. This idea is intriguing because it aligns with new models of how the Kuiper Belt, a region beyond Neptune, filled with icy objects and small planets, came to be. In the beginning, the building blocks of the Kuiper Belt likely formed rapidly, possibly within just a few hundred to 1,000 years. Beerson finds it fascinating that the evidence points in this direction, especially as scientists studying the movement of the Kuiper Belt are reaching similar conclusions. The concept of Pluto having a hot start is both strange and surprising, but it has important implications not only for Pluto itself, but also for other nearby dwarf planets like Eris, Makemake, and Haumea. These worlds might have formed just as quickly and in the same fiery manner as Pluto. With this new understanding, along with what we've learned about the icy moons orbiting gas giants, the old belief that Earth is the only ocean world in the solar system is being challenged. It's becoming increasingly possible that the farthest reaches of our solar system are full of liquid water. Alan Stern, the principal investigator of the New Horizons mission, believes there could be many worlds, both near and far, that harbor oceans. This could be one of the most significant discoveries in planetary science. At first glance, these distant icy worlds might seem like they couldn't possibly support life. After all, Pluto sits about 4 billion miles from the Sun, receiving so little sunlight that its surface is an icy 400 F, 33 Kelvin. However, the real surprise might be below the surface. Beneath Pluto's frozen crust, in the warmth of its hidden ocean, life could potentially survive protected from harmful radiation and asteroid impacts. Stern even suggests that these subsurface oceans might offer better conditions for life than Earth's surface, which is vulnerable to catastrophic events like the asteroid strike that wiped out the dinosaurs. If you were living beneath Pluto's icy surface, you'd be safe from many of the cosmic dangers that threaten life on Earth, like solar flares or a distant supernova. This new discovery about Pluto's possible ocean adds to the growing body of evidence suggesting that the dwarf planet has harbored a liquid ocean for a long time. However, Alan Stern, the leader of NASA's New Horizons project, admits that the current proof is still uncertain. He likens it to weak evidence in a courtroom enough to raise suspicion, but not enough for a conviction. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.